All right, we are looking at two populations here, and we want to some exam scores based on them using the software, and we want to compare these two. So what we're doing is we're saying that the first software, okay, that they used is no different than the second software. And so that's how we set up our null hypothesis, that there's no difference versus that there is a difference. Now, there's a couple of ways you can do this with the F statistic. One of the probably the fastest ways is if you have on data analysis, and remember that you have to get this by going to File, Options, Add-ins, Manage Excel add-ins, and you just have to be sure that it's checked. So if you have that checked and you click Data Analysis, I can do an F-test 2 samples for variance. My variable 1 is here. My second exam, variable 2, is here. Notice I did select the labels, so I will check that. They said to do this at 0.1 alpha significance level. And then I can output this information. I don't know, let's just put it right there. And when I click OK, what I get is my F statistic. So this 4.158, let's just put it right here. But let's say you don't have that plug-in on your computer. Then what you could do is you want to find the mean and the standard deviation, because we're going to need these anyway, okay, for these. And let me make this where it's like that. And so how do you find the mean? You do average, highlight your values. Oops. How do you find the standard deviation? STDEV, highlight your values. Do it the same for this one, equals average, highlight your values, and then equals STDEV, my standard deviation, and highlight my values. Now, the F statistic actually can also be found if you take the standard deviation. Okay, so if I take the standard deviation and I square it divided by the other standard deviation squared. So I'm doing the Shift 6 to get the square symbol. And notice I get the same answer. Okay, so if you didn't have the data analysis to be able to get this, that's how you can actually find. Remember, all I did was take the standard deviation, square, divided by the next standard deviation, and then square. To find the test statistic, we're looking at the difference between two means. This is going to be a t-test. All right, so I run out, and you're probably like, what's happening? I run out and got the formula so you can kind of see what I'm doing here. And so my test statistic is the difference in the means. And ultimately, I mean, you could put it there if you want. So this is sample means. The difference in the population means is 0. That's saying there's no difference. So a lot of times you won't even see that even written, but if it makes you feel good, you could put -0 there. And then divided, I got to do all this crazy stuff. So the square root of, notice I did 2 parentheses because I'm going to do each fraction in a parentheses. So the square root of this standard deviation squared divided by my sample size. Now I didn't put this in a cell, so I'll just have to type 10 because there's 10 values here. Close that fraction, plus now my next standard deviation squared divided by, I believe there's 14 here. And so close that, and now I'm closing the square root. So this is the difference in the means, and then the square root of the first standard deviation squared divided by the first sample size, plus the second standard deviation squared divided by the second sample size, and I hit enter, and this gives me my test statistic. And from here I can find my p-value. Again, this is a t, distribution. It's two-tail because my alternative is not equal. I put in this value right here. Now they have a crazy formula that you can find the degrees of freedom, but a lot of times you just take the smaller, okay, so the smaller in this case, or even sometimes you'll see them, they will subtract, you know, the two or whatever. I'm sorry, add the two and divide. What I'm going to do is I'm going to put in 13. Oops, I said 13 and I'm not even thinking here. So the smaller would be 9, right? Because the degrees of freedom is the sample size minus 1. So typically this will work, okay? If this value, it kind of complains with that, then you might do the 14, the larger of the two, and this might give you a closer value. And of course, I'm looking at the p-value and what am I comparing it with versus the alpha, which is 0.10. And certainly I am not going to reject the null, which means there is no difference between these mean scores.